Be looking at SigmaPlot. So SigmaPlot is a statistical software, or more specifically, a graphing software. So its advantages over the Excel one or the Excel program is that you can easily manipulate the graphs that you will produce here as compared to Excel, and it pretty much functions the same way as Excel. Uh, Aside from that graphing, or aside from the quality of the graphs, and but this software is not cheap. Like the last time I checked, it's around $799 or $899 to get the lifetime license, and that's the student license. And the one that we're using is a pirated version. So if you are planning to use, or if you're planning to use graphs and charts from this software and for your publication, you can either buy the software. Second, you can either do the analysis and everything and borrow a license, so to speak, from a person who has the legitimate license. Or third, what I do is I use this software primarily for checking the graphs. And I have another software that where I actually make graphs and such, but it's not as easy to use as compared to SigmaPlot. Doesn't have the same interface and same functions, but it's the legitimate one, so I go with that. So more or less, SigmaPlot for me is just the testing ground for my data, for the data that I want to chart. So we start up with a new worksheet. So normally when you open your SigmaPlot, it should have a dialog. So let's try opening it up. So and by the way, we'll be using this dataset for this graph. Next time, there. So it will ask you if what would you like SigmaPlot to do. So normally I just have it's set on default to create a new blank notebook, and you can actually create a new notebook from an Excel file and the database, or from a clipboard. Normally I just use the blank notebook because I just copy and paste it from my Excel. And furthermore, if you want to know more about the inner workings or the more technical or complicated stuff for SigmaPlot, you can don't forget to check this one out. And it's very straightforward. It's very easy to understand. I actually didn't know SigmaPlot when it was first introduced to me, and I was forced to use this because no one was there to teach me at the time. New blank notebook, and just press OK. Then you have a worksheet here, pretty similar to the Excel file. Now, again, we're going to be using the data here, specifically just the pH. So we just want to copy this column and put it here in the second column. And we're going to get the transects, and copy and paste. Okay. The key difference here with Excel and SigmaPlot is that the first row, SigmaPlot actually recognizes the first row as a data point. So if you try to graph it now in its current state, it's just going to give you a lot of errors because you have a text here and you have a text here and you have a bunch of numbers here. So the next step is actually to promote, quote unquote, the first row into titles. So you do that by hovering the cursor above the column title, which is number 1, until it forms this downward arrow cursor. You right click and you select column titles. Then it's going to pop up a dialog where it shows that you need to input the title here, or you can just simply promote it from the row. So we're going to select the promote row number 1 to titles. Select promote, and it automatically transfers the transect label into the title. and you click on next. So you go to the next column, the second one, which is the pH, and you click on promote again. After you're done with that, you close it. Again, the promote function can go up to infinity. So you can promote the entire data set if you want to have, if you're planning to use it for big data sets. Now that we have our data, it's time to make graphs or charts. So SigmaPlot actually has this function, this tab here in the toolbar for graph, and you select create graph, or if you want to do the shortcuts, you can press F3 and click on it, and it should open up the dialog where you want to create graphs. So again, SigmaPlot has a lot of options when it comes to graphs, and later on you'll probably be discussing or using this in your biostatistics class. If you're not, if you're adding, if your professor is going to add SigmaPlot into your curriculum or in your course outline. So for this type of data set, I probably want to make a vertical bar chart since I want to compare the different transects, so transect 1, 2, 3, 4, and 5, if which one has a higher pH. You click on next. Then with it's going to give you different options for different kinds of bar charts. So in this case, I want to select simple error bars because we're gonna take the average of all this in transect 1, and we're going to have error bars coming out of error bars coming out of the bar charts themselves, as you'll see later. And you click on next. Now, so it's going to ask you how are the error bars computed. So you select by category and mean. And ideally, error bars, you want to have the standard error. You want to show the standard error. Okay, so it's been pre-selected because I've used this several times already. And you click on next. And it's going to ask you for the format of the data. So in this case, it's the category for the x-axis and the y, the data point, the values of the pH on the y-axis. And next, it's going to ask you what values or what's the column to plot here in the categories. You select it by clicking on this drop box here and selecting transects. And for the y-axis, you select the pH. And you click on finish, and it should show you something like this. So zooming in, click, if you want to zoom in, you can click this magnifying glass icon, or you can click this. I prefer using this because I have much more control. And there you have it. So as you can see, you have error bars here on the top that shows the standard error between the replicates. Then from here, you can actually edit or manipulate the graph so easily as compared to Excel. Here, I want to type, you can change the label here, so by double clicking it, then transects. And over here, you can click on, double click, and put in pH. Then just click outside of the area, and there you have it. You can actually change it. You can either delete the title or delete it, or just change it to pH between pH between transects. Okay. Now, let's say you want to change the color of each bar. So when you first click on the bars, it's going to select everything, as you can see here as you can see by the boxes over here. If you click it again, the single bar that you want to edit, it's going to show just a single box, meaning that you've only selected one item. Then you right click and you go to object properties, and from here you can actually change the color. So I prefer it dark red for the transect one, and apply and close. Then for the second, okay. So here in the legend, it's going to show the different values that you have for each bar. You can actually change this again by clicking on or double clicking on the legend, or just right click and object property or graph properties. There we go, graph properties. So you can the graph properties, so you can actually look for different. You can do more manipulations here. So you can either widen the bars or you can make them thinner. In this case, I just want them just right. The Goldilocks and the error bars, standard error, category mean. So it's the same selection that we put on there. Then on the axes, so you can change the scaling, you can change the ticks. The ticks are these lines over here. These are the major ticks. This one you can actually add some minor ticks too, and labels. Yes. You can actually edit the labels over here. And for the next tab, the graph. So here, the legend, you can actually uncheck the legends if you don't want any legends to show. So if you click apply, it's going to disappear because you already have a label here. So a legend doesn't really have much use here. And for the plots, it's just going to hide the plot or show the plot. And the grid lines, we don't use that much, and backplanes. And apply. So that's how you make a bar chart in SigmaPlot. So now we're going to look at the time series, because time series charts are very useful. So we add a new worksheet, and time series data are very commonly used. In this case, we're just going to copy everything and paste it here. Again, you promote, next, promote, and you close. Okay. So going back, time series datasets are very commonplace in environmental and marine sciences, because we sometimes we take a look at or we monitor the changes in the environment through time. So let's say we're observing how much different it is from 10 years ago to now. It can be any variable that we want. It could be the coral cover. It can be the number of invertebrates, the biomass of fishes. And for the environmental science folks, it could be the pollution. It could be the number of certain chemicals in the water or certain spill-offs and such. And you all monitor that through time. So if you remember from your high school sciences, a lot of time series charts are usually drawn in line form or in as a line chart, and you can easily do that here also. So we go to graph, create graph, and we look for the line plot. Okay, then we put in next. So again, for the line graph or line plots, you can actually have a lot of options here, ranging from very complicated ones to very simple ones. Okay, so but we're gonna be dealing mostly with the simple straight line and multiple straight lines. So with the simple straight line, it's just comparing the x and y axis or the y data through time, with x being your date or the timeline. So we click on next and we click on XY pair. So column X is usually used for the time and date because we're trying to look for the trend. Then for Y, let's look at species richness first, then finish. And there we have it. So zooming it again, there we go. So start of July, we have a high point here, and as you can see, it's going down. So you can safely say or suggest from this graph alone that the species richness or the number of species you observe are declining through time. So again, you can edit it. So species richness through time, and just click outside the selection, then double click on the y-axis data or label, and you put species richness, and for the x data time. On the side note, normally we don't put titles on the graphs, so you can just delete that. And most scientific publications actually don't have this line over here. So you can actually select on the top border and the one on the right. So it's going to show a graph just like this. The title is kind of redundant because you already have uh, the labels for the x and y axis over here. And in scientific publications, when you're doing your scientific writing, you also include some captions, which we'll discuss next time. So we're going to be deleting this. So going back to the so lastly is the scatter plot. So the scatter plot is actually used when you want to correlate two different uh, factors or two different variables. So if you're trying to look at the relationship between factor x and factor y, and if one affects the other, but again, it's going to be discussed more in detail in your biostatistics. But early on, it's very useful to have a, it's very, actually very useful to have an understanding of correlation early on and the use of scatter plots. So you type in, you click on scatter plot, you click on next, and here again, you have a lot of selections here. So since we're trying to look at the relationship between the x and y pair. So we're gonna put with a simple regression. XY pair. Okay. So now we're trying to look at the relationship between the species richness and the nitrates. And click. And there we go. So again, correlation looks at the relationship between factor x or y, or factor x and factor y. So factor x being species richness, and factor y being the nitrates in ppm, parts per million. ppm is a concentration. You can actually delete the legend and delete the title and delete this. So based on the graph alone, you can actually conclude, or you can actually assume that as the number of the concentration of nitrates in the water column increases, species richness in a given area decreases. Although this may not be true since correlation is not always equals to causation. But if you try to use your own data sets, the ones that you collected, and run them via SigmaPlot, you might get different results altogether. You could have a positive correlation where the line is actually going from bottom left to upper right, or negative correlation like here where it's going from upper left going to bottom right. And if there's no correlation altogether, it's just going to be a straight line. And that's it for SigmaPlot. These are functions of SigmaPlot that I use, and there's a lot more actually. And should you have any questions, don't hesitate to contact me. Send me an email, send me a message in Discord, on Facebook, or even in my Silliman email. Thank you very much.